My dear students, this is me Ishfaq Riaz, and today we are going to derive equations of uniformly accelerated linear motion by calculus method. Dear students, आपको याद होगा आपने equations पढ़ी भी हैं. V is equal to u plus at, S is equal to ut plus 1 by 2 at square, v square minus u square it is equal to 2as. तो आज हम ये इक्वेशंस जो हैं आपने ग्राफिकली तो डिराइव की होंगी. आज हम इन्हीं इक्वेशंस को कैलकुलस मेथड के जरिए डिराइव करते हैं. तो हम यूज करेंगे डिफरेंशिएशन और इंटीग्रेशन. तो सबसे पहले हम ये वाली इक्वेशन डिराइव करेंगे. v is equal to u plus at. So what is v? It is final velocity. U it is the initial velocity. A is the uniform acceleration and t is the time interval. Right? So let me start it here. We define acceleration as rate of change of velocity. So let me write it here. So acceleration A, we define it as rate of change of velocity. So it is dv by dt. Right? So from this very equation, we can write this dv, it is equal to a dt. बात समझ आ रही है ना? So let us integrate this equation within proper limits. So let me write it here. Integrating both sides within proper limits. तो limits of integration क्या है मैं आपको यहाँ पे समझाता हूँ. For example, body starts from point O and let here the initial velocity is u and let the body starts at t is equal to 0. Right? So body reaches at point B and suppose final velocity here is v and the time interval is t. Right? You are getting my point or not? So the body started from point O at t is equal to 0, its initial velocity is suppose u, and while it reaches point B, it has attained a velocity, final velocity that is equal to v after time interval t. Right? So let us integrate this very equation within proper limits. So I can write this is integral of dv. Right? So this is equal to integral of a dt. Limits of integration here are body starts from point 0 to t. Right? And here the limits of integration are u to v, where u is the initial velocity and v is the final velocity. Okay, so we know integral of dv, it is equal to v and the limits of integration, so let me write it here, from u to v. Right? Since acceleration is constant here, so I can take it out of the integral, and integral of dt it is equal to t, and again the limits of integration here are from 0 to t. Right? So here by substituting, rather by doing this very definite integral, we can write this is here v minus u, it is equal to a upper limit minus lower limit, so this is a into t minus 0. Right? Okay, so I can write it here v minus u, it is equal to a t. Right? So or I can write v is equal to u plus a t. Right? So this is the first equation of uniformly accelerated linear motion by calculus method. I simply used the definition of acceleration is rate of change of velocity. Then by integrating the equation within proper limits, as the body started from point O, at that very point the initial velocity was u, and when it reaches the point B, the final velocity was v. Simply by solving this definite integral, I got the first equation of motion, that is v is equal to u plus at. Hope आपने ये वीडियो अच्छे से समझ लिया होगा. Thank you very much.